Hey guys, Andy here with Lithogen. So we've already dumped the data. You can see here in the folder, two R61 files. R probably stands for raw file. We have two files here in the folder. We have the A file, which is in the standard differential mode, STD-D, and the B file is in the standard 4-channel mode, STD-4. I should point out that if your target is mostly UXO or underground metal detection, you should probably have it in the differential mode, as this mode is less affected by the near surface response. And additionally, you have that second coil that can help you determine the depth of the target. If you're using the EM31 in an agriculture setting or perhaps soil remediation, and you're more interested in the variation of conductivity of the soil, then you should use the 4-channel mode. So the 4-time gates will give you information on what the conductivity is at 4 different depths. Because the early time currents are concentrated near the surface and later time currents diffuse deeper into the earth. The differential mode will still give you 3 time gates on the lower coil, but you sacrifice the 4th one to get what is effectively a vertical gradient measurement at the 3rd time gate instead. Okay, so the first step will be to change the raw data format into a more human readable format. To do that, we're going to use a software called DAT61mk2, I think. So if you're renting from us, we will always send you a copy of this software on a USB stick. So I'm just going to assume you have the software already. Go to Convert, and then there's only one option. Choose the input file as the raw file. You can only select one at a time. Actually, let me go to this one. And output file looks like the default. It's pretty good. And press Convert. And I'm going to do the same thing to the B file. And convert. Before we move on, let's take a look at what the raw data format is compared to the one we've converted. Let me bring this up to the screen. Okay, here we have two files side to side. So on the right side, we have the raw file, and on the left, we have the M61, the converted M61 file. So the raw file looks like there are some number matches, but most of them, like this one here, seems to be just gibberish, versus the converted file, everything is laid down nicely. You have data point number 1, 4.1, that's probably the first time gate, second time gate. This one, I believe, is the third time gate, and then you have the second coil that's above the primary one, and you have the time of the data collection, and then in between all the points you have a GPS stamp looks like something north and something west. And then you have again another timestamps. Looks like we have that's probably 10 data sets, 21 to 31. So we have 10 data sets in between what is 1 second. So our EM61 is probably collecting data at 10 hertz, which is 10 sample per second. And I think that will be good enough, and we will move on. Okay, so although the M61 file is fairly readable, but it's not very friendly for the next software we're going to use. It's called the QGIS. So we'll have to convert the M61 file into what is called the XYZ file, which is essentially a tab or space delineated text file. So to do that, go to GPS positioning and then choose GPS positioning again. So the input file, let me go to the correct folder. So the input file is going to be the M file that we converted. And then choose a output location. And then for the name, you want to name it the same way. Although I'm just going to delete the file name extension. Here is where we get interesting. So the DAT61 will actually ask you what channels do you want to export. Here, and then if you click on select channels, here you can see there are going to be 4 brackets, and each bracket is actually a mode. So we know that our alpha data or A data is collected in the standard differential mode, STDD. So I will click on this. And then everything else, you can just copy exactly my setting. The important thing is you want to use a UTM system. And then for the unit, you can use meters. Okay, so looks good. I will click on apply. Done. Okay, we're going to do the same thing to the B file. And we want to use the standard 4 channel mode. And click on apply. Now, I'm going to show you what looks like if you choose the wrong mode during this phase. So we have a file, alpha file, which is in the standard differential mode. And for the channel, I'm actually going to use the standard 4 mode. And for the output, I'm going to call it, I don't know, wrong mode. Save and apply. And okay, now we're going to take a look at the data. So let's take a look side by side with the data we just dumped. So we have A here. Let's open the B as well. Okay, so looks like we got the first thing is easting and northing. Looks good. We have standard 4, STD 4-1. So that's probably the very early time gate. Second time gate. Third time gate. And then the last one is the 4th time gate. Versus on the other side, we have, so that's standard differential mode, first time gate, second time gate, third time gate, and that's the response from the secondary coil. And the column is actually called -T. And let's look at the run mode if we did one step run. So obviously, we only have two columns, and there is no data under the other channels. So if you got something look like this, you know where it went wrong, and you should probably go back and fix it. Okay, before I move on to the QGIS, I actually want to fix the header a little bit. QGIS are very particular with the headers, so I'm going to delete all the commas and the slashes right now for both of my files. And then this last bit here, you can just delete all these. And I'll do the same thing to the B file. Okay, done. Okay, we're actually all done with the EM61 software, and we're going to move our attention to QGIS. So I'm going to open QGIS. When you download QGIS, you should check the version of it. It should be at least nearer than my version, just to guarantee it works. The older version might not work with the different plugins and sort. We're actually going to use two plugins for processing this data, and two tools instead of plugins. We're going to use one plugin, and then the second tool is to the satellite imagery of the Google Earth from Google Earth. Okay, I'm going to create new. I will save it in case I forget. EM61 tutorial. Okay, so the first tool, plugins. Click on plugin, manage and install plugins. In the All tab, search Arc Geek Calculator, first one. Click on that. And then this button here, it should say plugin. Since I already have a plugin, it doesn't say that. But this button should be it. Click on that and go through the installation process. Second tool is satellite imagery. There should be enough material on the YouTube showing you how to do this, but a really quick tutorial is right-click on this and then new connection. So in the name, you can name it whatever you want, Google Satellite or whatever, and then put in a URL, and this URL will be different depending on which photo, which layer you have. I'll put mine in the description of this video, and then you can just copy that in here and then click on OK. But I'm just going, so I already have it added in my tiles. I'm just gonna double click on that. Okay, so now we're going to add our collected data into QGIS. To do that, go to layers, add layer, and then add delimited text layer. Okay, choose the XYZ file. we just did. I'm going to use alpha file here. And let me just hide these two settings for now. I'm going to go through them one by one. Okay, so here you have a sample data. If you did everything I showed you before and click on removing the space and comma, you should have a nice table like I do here. But if you have any other junk in your data, play around with this file format settings. See if you can get a nice and neat column like I have it here. So once that's done, second, record and field options. Looks like everything's all right. Now the geometry definition is the more important part because this is where the QGIS will georeference your data points. So in the X field, make sure you have easting or east, and Y field is north. And then we're going to choose a CRS system for our file. So I know our system is in UTM zone. And then because we're in Winnipeg, so our zone is 14 north. And looks like I have a whole bunch of options. I'm just going to choose this one. See how it goes. Click on OK, and then click on Add. So now that layer should be appear in the layer menu. And if I right click on this and then zoom to layers, and voila, it brings me to where our data is at. And then I'm going to do the same thing to the other layer. Sorry, don't know where I'm going. Layer, add layer. Can't pronounce that. And I'm going to assume everything's right. Click on that. And we're good. Okay, because we have two files here, we have effectively 8 different grids. So I'm going to show you 2 ways you can do this. So the first way is we're going to grid only one column at a time, and then the second one is called a batch process. Essentially what this means is we can do a whole bunch of columns at the same time. Okay, so the first one is go to plugins, ArcGeek calculator, and then go to grading analysis. Here choose the layer you want to grid. I'm going to do the A file or the differential mode first. In the value field to interpolate, I'm going to choose standard D mode. For the output size, I will do 0.5. And because we're in a UTM coordinate system, 0.5 here will basically means half a meter. And this column, by the way, this column depends on the coordinate system that you use for you that you have in your data. That's why when we exported the file from the DAT61, we choose the UTM coordinate system instead of the raw latitude and longitude. And if you did export in latitude and longitude mode, you will need to change that into a UTM coordinate system before you can do the grading. Okay, and then for the other settings, unless you know what you're doing, you can just leave everything default. It's not gonna make too much of a difference. And then for the output layer, I will choose a location to save this. And so I can just choose my name. I already did it once, so I'll just borrow the same name here. But for you, you can probably name whatever you like. Although a good rule of thumb is you have the data, which data you did, the data name, and then which column you plotted, as well as the distance. Although arguably you can probably just remove that last part. And then click on save and run. It's gonna take a little bit to grade the layer. Okay, so the grading is finished, and looks like that layer is automatically added into my layers here. I'm just going to show the data points we have on top of the grid we just did. Okay, so the batch process. So I'm going to do all the other 3 columns with just one setup. To do that, again, go to plugins and then ArcGIS calculator and then kriging analysis. Instead of doing it here, click on the run as batch process. And I'm going to make this a little bit bigger to easier to look at. So I'm going to do it to 3 different columns. So I will add this action, this grading action 3 times. And then each of them should be, I will want to graph the alpha layer. So change all of them to alpha layer. And then the value field to interpolate, since I already did the differential first time gauge, so I will do second, third, as well as the difference. So second, third, and difference. And then the output size again, so it's 0.5 meters, half a meter. Keep it consistent with what you have. I mean, what I have for that first one. And again, everything else here, unless you know what you're doing, leave them as default. And then for the output, so I like how I named the first one, but I want the name to be added automatically. So I will actually delete the column part, and I'll tell you why in a second here. Delete this part. Look, I actually kept underscore. Again, I will show you why. Click on save. Here, you can actually choose to automatically fill the name. So I'm going to say fill with parameter values. What this means is I'm going to fill the name with one of the settings I did here. And then the parameter to use is I want to add the value field to interpolate. Whatever I choose here will be added into the name part that I just did. Click on OK, and then click on Run. Oh, actually, look, the name are actually put in here perfectly. So I have the point layer underscore, which is the one I just have, and then the column name is added automatically here. And hopefully this does the all 3 layers for me. Okay, the process is done. And my data is not added automatically. That's okay. So go to raster, go to layer, add layer, and then add raster layer. Go to my folder, and I will just add the other 3 here together, and click on that. I'm going to move them, organize my space a little bit. Actually, the order is all wrong. Okay, first time gate, second time gate, third time gate, and differential mode. And I'm actually going to create another group here in the layer. I'm gonna call it the alpha file 0610158, and I'm going to move all my A layer into this group, just so that it's easier to organize. And now I'm going to do again a batch process for the B file, and I'm just gonna do this muted, and I'm probably going to fast forward this process here during the post editing. Okay, so I have added all the 4 channels in the standard 4-channel mode. Again, let's go over this one by one. So this is very late channel, third channel, second channel, and first channel. Okay, before we move on to the next step, let me explain a little bit of why we're doing it. Probably just also grading in general. So the way grading works is that the computer estimates the values between measured data points. So here, let me just display the measured data points here. And so you see the line here, those are our measured data points. The computer is guessing what that data point is at a given area. So it can do fairly well if you're guessing somewhere between 2 data points, because essentially you're just interpolating between the 2 points. However, if you're very far away from your data points, the computer cannot guess it very well. An analogy to this is weathercasting. For example, predicting tomorrow's weather is usually quite accurate, but predicting the weather a week from now is much less reliable. So similarly, the further the software has to estimate from real measurements, the less reliable those estimates become. And that is the reason why we are going to do our next step, which is to remove areas that are too far away from the measured data points. So what this do is it will ensure that the final map only displays areas where we have reasonable confidence in the interpolated values. Okay, with that said, let me show you exactly how to do that. So the first step is to create an area where we can tell the computer where we want to keep the data. So to do that, I'm going to do the example on the B layer, and I'll probably again fast forward how I did on the A layer. Okay, first step, go to vector, geoprocessing tools, and then buffer. Here for the input layer, choose whatever you want to do. I'm going to do the B file. And then the distance, this is essentially telling the computer how far away do I have confidence with my data. And for the EM61, I'm just going to go with 3 meters. And on the dissolve results, you want to make sure that you click this one. And you can choose to save your buffered layers, or if you leave it blank, it will just create a temporary layer. What temporary layer means is that this layer is not saved properly in your disk, and you might lose this file after a little bit. So the best practice is to save it, but for the purpose of this video, I'm just gonna do the temporary layer. And I will click on Run. And here's a buffer layer. Actually, now I look at it, 3 meters is probably a little bit too much data. I'm actually going to remove this layer and then do that all again, but with 1 meter instead this time. Actually, let me show you how to do it with the batch process, and I'll show you how to do both the A and B at the same time. So to buffer, I'm going to again run as batch process. I have 2 layers, so I'm going to do 2 action. So I have alpha and Bravo. Distance, again, so I'm going to do 1 meters. And dissolve results, I want to click on yes on both of them. And temporary layer is fine. I'll click on Run. Oh, it's telling me something's wrong. Row 2. Not sure what that error code is, but let me try, maybe give it a name. So I'm gonna do buffer input layer. Let's see if this fixes it. It does. Okay. So now we should have 2 buffer layers, and they will add it automatically. Add layer. So the buffer layer is actually, I think it might be a vector layer. Let me take a look. And I don't know where I saved my buffer layer. Okay, I've found the missing file and I've moved it to the right location. Okay, so let's try that again. Add vector layer and buffer A and buffer B. And let's add them. And good. Just gonna again organize my folder a little bit. Done. Okay, so now we have the buffer area, which is essentially where we can tell the computer where we want to keep the data, and then everything else we can tell the computer to remove it. So the next step is going to be removing the rest of the part. So go to raster, go to extraction, and then clip raster by mask layer. And because I'm a nerd, I'm going to do the batch process again. But obviously you can do this as a single layer, and then you can just do all of them one by one. So I'm going to do 4 actions. I mean, I can probably do all 8 of them, but I just want to do 1 layer at the same time to give myself a little bit more control. So I'll do alpha file first one, second one, third time gates, and then difference. Let me just make sure they're correct. And then the buffer layer is the alpha. Again, alpha and alpha. Make sure they're consistent. Source CRS and target CRS, I'm gonna leave them empty. Target extent, don't remember what that is. Probably doesn't matter. Here on the match the extent of the clip raster to the extent of mask layer, you want to choose no in all of them. And for the result, I'm going to name it, and I will add the word clipped, oh, spelled wrong, clipped underscore. Again, autofill with input layer, and run. Okay, now, so I should add all the layers back in raster layer, and here is my clicked data. So I will add all 4 of them. And probably just organize my my group here a little bit. So I will have the clipped group. Just move them in there, and probably a unclipped group. Oop. Now let's look at the layer one by one. And so that's the difference, the differential layer, time case 3, time case 2, and time case 1. Okay, good. So let me do the same thing to, again, I'll clip all the 4 layers in the A file. Oh, actually, I might have made a mistake here. The clipped, I have, okay, so this is actually going to the A group. I put it in the wrong group. Okay, so I'm going to do the same thing with the B file, with the B data now. Done. Okay, so the next step I want to do is to change the color of this graded map to some other color to represent the data instead of just the boring black and white. But I want to do it in a very particular way so that the color represents the same conductivity in that across in all the 4 layers, so that you can really see the variation when you switch into different columns. And that way I can I can toggle on and off between layers and make sure I can make meaningful comparisons while getting a true sense of how the values vary within the depth. So let me show you how to set that up. Okay, I'm going to do that with the alpha file. Okay, and let me just hide that one. Let me just organize this a little bit. Okay. Actually, for the alpha file, it doesn't make sense to have the differential file on the same color ramp as the other time gates. So I'm actually going to do this layer individually, and then the other three layer, 1, 2, 3, I will use the same color ramp. So let me show you how to do this individually. So if you go to right click on the data on the layer, and then click on properties. Go to symbology, and then under the render type, choose single band pseudo color. And for the color ramp, there's a whole bunch of options. You can choose whichever fits your aesthetic style. But I've heard from Troy that this one is a good option. So I'm just going to go with that. And then for the value setting, I am going to clip the top and bottom, the 2% outliers with this setting here. And I will click on apply. And that changes the color of it. Now, to do layer 1 to 3, I will do the same thing. Right click, go to properties, symbology, change to single band pseudo color, and then choose this one I want. And I'm going to do it in a different way. For the modes, I'm actually going to choose quantile, and I will add, instead of 5, I'll probably do, I don't know, 4 bins. And then do the 2% again, although probably not necessary. Okay, here you can see it's assigning the value of -800 to this color with this label. However, the computer didn't choose this value to this color based on anything. It's just because this is the number that has the lowest value to it. So instead of this, I'm actually going to change this to an even bigger number. So I'm going to spread out the bin a little bit, so the number doesn't look like it's arbitrary. And then this one, I'll probably do minus 250. This one I'll do plus 150. And this one I'll do 11,000. And because, again, I want to apply this to all my layers, so I will save this color ramp so it's easier to use next time. So I will save it. Let's call it color ramp. Essentially, what this file does is it will tell the computer to assign which value to which color. Okay, so that's good. And I will click on apply, click on OK. Now for the second layer, again, go to properties, go to single band pseudo color. And instead of changing it here, I can just choose the folder icon, and I just click on the color ramp that I just saved. and you can see the value is automatically applied. And I will do the same thing to the third layer. Okay, so now let's toggle each of them on and off and see the variations. So very early time, middle time gates, and the later time gates. Okay, now I'm going to do it with the B layer, and I'll probably do it muted as well, and probably fast forward this in the post editing. Okay, we have done pretty much everything we can with QGIS. Now, what if we want to open these plots on another software? How can we save those layers outside of the QGIS? Okay, to do that, we're going to export this layer into a TIFF file, and specifically, it's a georeferenced TIFF file. Georeference basically means that it has the coordinate system built into this export layer. Okay, so to do that, right-click on the layer you want to export, go to Export, and then click on Save As. And then for the output mode, you want to choose the rendered image. So this will ensure that the color you added will be saved. Otherwise, if you choose raw data, Google Earth will display them as black and white. Okay, so the format is GeoTIFF, which means georeference TIFF file. And for the file name, I'm going to name it, so that's the B layer. So I will do B layer 4, standard 4-4. And click on Save. Oh, let me just add geo as for georeferenced. Okay, resolution, everything I'll just keep the same. Click on OK. Now I can do this with all of the layers, or you can do it with all of the layers. I'm just going to show you how to do one of them as an example. Now, if I open Google Earth, I should be able to just drag this file into Google Earth, and it should know exactly where this file are. Sorry, where this grid, where the data is. And obviously, this output file, you can do it with other software other than Google Earth. It should all recognize it. It's a pretty standard file format used in the GIS industry. And to look it better, I'll probably just change the clarity of it so I can see the surroundings of my data. Okay, that's it from me, Andy with Lithogen. Have a good one, guys.